Today, we're going to be looking at linearity and continuity of graphs. So let's take a look at example 1. It says determine whether the function is discrete, continuous, or neither. So if it's discrete, that means it's going to be a collection of a bunch of random points. If it's continuous, that means you're going to be able to just run your pencil across the graph following a line. And if it's neither, it's going to be a combination of both of those. So if we take a look at this one, example 1, we start off and then we end, and then we jump, and then we go. So this is actually going to be neither. And the reason for this is the function has a gap. Between, so these 2 points right here. So this would be -1, -2, and then this would be -3. X equals -2 and X equals -3. So the function has a gap between X equals -2 and X equals -3, like a discrete function. But the graph is continuous after X equals -2. So it's got a discrete section, it's got a continuous section, therefore it's going to be neither. Let's take a look at example 2. So this would be a great example of a discrete graph. Why? Because we have a random collection of points. And what are we looking at here? So we're recording the number of hours we work in our after-school job. So we have 7 hours, we have 6 hours, 7, 5 hours. So it's just a bunch of random points. So as I said, this is a discrete function. Because we have just these random points that we are collecting. All right, let's take a look at example 3. So now we're moving away from discrete, continuous, and neither. Now we're going to look at, is it linear or is it nonlinear? Linear means it makes a straight line. Undo this. So again, blue. So linear. So that's linear. This is also linear. And then nonlinear. Nonlinear would be something like this, like this, like this. These are all functions, but they're nonlinear functions. They're not straight lines. So for it to be a linear function, it needs it to be in the form of ax plus by equals c, where a, b, and c are just some number. It can be any number, but it just needs to be some number. So let's take a look at this first example. So what I'm going to do is I'm going to start with subtracting the 2x from both sides. I want to get it over here with this y. So that gives me -2x plus y equals 5. This looks like this. We have our a value, we have our c value, and we actually have a b value. When you don't have anything there, it's just going to be a 1. So our b value is 1. So this would be linear. All right? Again, because it's in that form of ax plus by equals c. Now let's take a look at b. So again, I want to get these two onto the other side. So minus 3x squared minus 3x squared. That gives me negative 3x squared plus y equals negative x plus 5. Now I'm going to move that x, so plus x plus x. So that gives me negative 3x squared plus x plus y equals 5. So I have my a value is 1. I have my b value is 1. I have my c value as 5. What's that value? That's not a. That's not b. That's not c. We got an extra number in here that we don't know what to do. So this would be nonlinear. Because we have that extra value in there that we're not sure where it goes, it is going to be a nonlinear function. All right, so these are, if we have the equations, what if we have, say, like a table? So for this table, we want to determine if the jump over here is the same, is the jump over here the same as well? What does that mean? If we go by 2 over here, are we going by the same amount over here? So if we look at this first one, we have a jump of 3. Then we have a jump of 2, 2, and 1. So these jumps of 2 should be the same. This jump should be greater. This jump should be less. And if we look from negative 10 to negative 4, that's a jump of 6. From negative 4 to 0, that's a jump of 4. From 0 to 4, that's also a jump of 4. And from 4 to 6, that's a jump of 2. Basically, for every x we add on to, we're jumping 2 over here. So since we're jumping the same amount over here, this is a linear function. For each x, we add 2 to the y. Again, how'd I get that? Well, 6 divided by 3 is 2. 4 divided by 2 is 2. And 2 divided by 1 is 2. I figured out the difference. Sorry, not the difference. I figured out what the average was for each of them. Let's take a look at example 4. So this one, we want to determine, is this linear or nonlinear? After we determine that, we want to graph it out as much as we can. So let's go ahead and determine if it's linear or nonlinear using that same idea. And if we look here, the jump for each one of these is the same. We have a jump of 1. What does that mean? Since we have a jump of 1 here, the change that we have down here should be the same. From here to here, though, we have a change of 0.25. From here to here, we have a change of 0.5. From here to here, we have a change of 0.75. Then we have a change of 0.5. How am I getting these? I'm finding the difference of them. So I'm taking this number and I'm subtracting it by this number. So 4 minus 3.5 is 0.5. 4.5 minus 4 is 0.5. And then 5 minus 4.5 is 0.5. So while it does level out and become linear, at the beginning, we're not so linear. So this is going to be a non-linear function. It has to be linear all the way through. It can't just be linear at one point and not at another point. All right. Now let's graph this. So the trouble is, because it's not much of a difference, it's going to be hard to see that it is non-linear. It's going to look very linear to us. So let's graph this out. So the first one is at 1, 2. Then the second one is at 2, 2.5, 3, 2.75, 4, 3.5, 5 is going to be at 4, 6 is going to be at 4.5, and then 7 is going to be at 5. So it's kind of hard to tell, but it is non-linear. So the big ideas today we were looking at was linear versus non-linear, and then we also looked at discrete, continuous, and neither. So go ahead and summarize both of these ideas. How do you determine if it's discrete, continuous, or neither? And then how do you determine if the function is linear or non-linear? So you're going to write the summary right down here. Then you're going to use these notes to help you out with the practice problems for today.